Okay, welcome back, ladies and gentlemen. We are talking about our line of best fit. So remember, in our previous video, we already looked at our scatter plot. We created our scatter plot. One of the things that's going to really help us, remember that we already said this has a positive correlation or a positive trend, positive association, which means when we do our line of best fit, it needs to be a positive linear. Now you guys already know that I struggle with drawing. So one of the things we want to do that's really important is we want to make sure that whenever we have this in this particular way, that our y-intercept is a whole number. Because if I tried doing it and I said my y-intercept was right here, well, I'm looking at this point going, oh, that's about 73. You might be looking at that point going, no, that looks more like a 74. And so we have to be careful, which is why if you kind of do a whole point, it makes it a little bit easier. So I'm going to try, because we skip so much, and I'm going to try really hard to see about making it right here. Okay, so let's try and draw our line. Now remember, with line of best fit, it needs to divide the points evenly. So we do not want a crazy line. So let's see if we can draw this. So my line, if I put it here, there are 1, 2, 3, 4, 5, 6, 7. There are 8 data points that are above the line and only 1, 2 below, including our outlier. This is not going to work. We want something that's going to kind of be even. So let's see. If we do this way, we have 1, 2, 3, 4, 5, and then we have 1, 2, 3, 4. This one would work. Okay. This one, as much as it's going through the points, that's really nice, but that means that we have one that's above it and a whole bunch that are below. That's not an even line. So we want to get as close to the data points so that they're even as we possibly can. So I'm going to kind of make it do this. Okay. Yes, I did use the tool. I had to. But you guys all know this. Okay. So if we're doing this, and this is my line of best fit, couple points I want to look at. So the first point I want to look at is my b value. Remember, this is where it crosses the y-axis. In this case, it's going to be 60. Now my slope, I want to find where it clearly crosses. So let's see. I could clearly cross right here, or here, or here. Oh, this is kind of nice. This one turned out really nice. So I'm going to use one of those, or two of those actually. So remember, it's that rise over run. So in this case, I went up 1 square over 1 square, but our squares are not listed one by one. On our y-axis, we are changing by 5. On our x-axis, what are we changing by? Good, we're changing by 10. So in order to do this, I said I went up 1 square and I went right 1 square. But remember, this is really going to be up because we decided that these were going to count by 5s. So it's really going to be up by 5 and right, because what are we counting by here? We're counting by 10s, okay, which reduces to 1/2. Now, if you recall from previous lessons, do you remember how we talked about how we write our equation? Y equals mx plus b. You guys remember that? We have everything. It's really nice. All we have to do is plug in for our m value, plug in for the b value. So y equals 1/2 x plus 60. Now, this is how this works for the line of best fit, because whenever we have a line of best fit, we kind of have to give the equation. Otherwise, you don't know what we can use for the line. And this equation is going to help us so much. I understand there's an outlier, but we're not looking at that right now. That will be something we put into our paper at the end saying, this is our line, this is the equation for the line of best fit. However, there is this outlier, and we can suppose why we have this outlier. We can say maybe it's this, maybe it's this. It kind of depends. But the nice thing is we can now use this as a predictor. So let's say we want to know how long or what score could we get if we studied for 100 minutes. So ideally, what based on this trend could we get? Well, we can use our equation. So y equals 1 half x plus 60, but in place of x, we're putting in that 100. Y equals 1 half times 100 plus 60. Here, let me move this down so we can see it. So y equals 50 plus 60, and y equals 110. I like this because this is a predictor. Now, let's talk about, is this realistic? Probably not. Unless your teacher is offering you some extra credit, more than likely that won't happen. We're going to have to kind of cap out and have the highest one be at right here with 100. Okay, and this is just for test scores. If we're doing something different where it's the age and the number of pets owned, which doesn't really have a correlation, but if we looked at television size and price, that would be something that we could definitely use this for. In this case, since we have to kind of cap out at 100, it's not going to work very well, but this is how you do the line of best fit. Remember, if you have questions, please, please, please ask, okay? And good luck with all your homework.